Hi, my name is David Goad. Welcome to my 10-minute tech talk on what is blockchain. This short video is designed for business managers who are interested in blockchain and considering it for their organization to be able to better understand the questions they should be asking their technical folks about whether they should be using blockchain or not and what type of blockchain they should be using. So what is blockchain and how did this all start? Well, it started way back in 2008 when a paper was written by a gentleman by the name of Satoshi Nakamoto. And what he described in that paper, which was published on the internet, it was never a formal academic paper, was a peer-to-peer electronic cash system based on a form of cryptography known as blockchain. And the idea was that he was trying to solve what they referred to in finance as the double spend problem. The fundamental problem you have with online finance right now is how do you know that the dollars or the money that you have in your bank account with the bank is actually your money and that it hasn't been given to someone else? In other words, in the olden days when you had fiat currency and you had physical currency where you had a dollar, you could only physically give that dollar to one person. But obviously, in today's day and age, with electronic or digital currency, right? How could you actually, ensure that electronically that currency or that money isn't given to multiple people? This is what they refer to as the double spend problem. So traditionally, the way that double spend problem has been handled is through trusted institutions, for example, banks or governments who issue currency and banks who track, our bank accounts. What Satoshi Nakamoto, and by the way, I should point out that there's a whole line or story around Satoshi Nakamoto. That's actually a pseudonym. We don't know if that's the actual person's name or not. But what Satoshi Nakamoto was trying to do is come up with a solution to this double spend problem where you essentially didn't need the bank or the trusted institution or the trusted intermediary to be able to finance or facilitate these types of transactions. So he actually wrote this paper. He went out through the process of setting up a blockchain, supported Bitcoin, got Bitcoin going, and then he actually disappeared. And people don't know where he is right now. It is actually one of the risks associated with using blockchain is this idea that Satoshi Nakamoto, if he ever did come back, he has such a large amount of Bitcoin available that he could essentially crash the Bitcoin market. So it's one of the things you have to consider when you're using Bitcoin. One of the biggest questions you're going to get is what is the difference between blockchain and Bitcoin? So Bitcoin is a cryptocurrency that uses blockchain, which is the technology, to support it. So blockchain is the underlying technology. Bitcoin is the cryptocurrency. There are a number of different cryptocurrencies, which is not really the topic of this video. And there are also a number of different types of blockchains, which we will talk about in this video. So what is blockchain? Well, blockchain is essentially an immutable, trustless, decentralized ledger. So let's go through each of those terms first. Immutable means unchangeable. You cannot change it once you process the transaction. Trustless means it doesn't rely on one central authority to be able to be managed. And decentralized means that the actual ledger does not sit on one system or one set of hardware, but is actually distributed across a number of sets of hardware, a number of sets of systems. So blockchain is a continuously growing set of records called blocks, which are linked and secured through a form of cryptography. Each block typically contains a cryptographic hash of the previous blocks, a timestamp, and the transaction data. By design, a blockchain is inherently resistant to modification of the data. It is an open distributed ledger that can record transaction between two parties efficiently and in a verifiable and permanent way. Once you put a transaction has been accepted into the blockchain, it can't be changed going forward. You can simply add to it. So you can't change history. There's actually a permanent solution or a mutable ledger. It is a distributed ledger. It's typically managed by a peer-to-peer network, collectively adhering to a protocol for inter-node communication and validating new blocks. Once recorded, the data in any given block cannot be altered retroactively without the alteration of all the subsequent blocks, which requires collusion of the network majority, or what they refer to as a 51% attack, which I'll talk about a little bit later. This diagram illustrates the whole blockchain process. So one party of the peer-to-peer network identifies a new transaction. They solve the cryptographic puzzle. They push it out to all the other parties in the peer-to-peer network. They agree with that solution to the cryptographic puzzle, say that that block can then be added to the blockchain. The block then gets added to the blockchain, and then the next block is processed. Again, because you can't change any historical blocks without changing all subsequent blocks, that creates this immutable ledger. And it doesn't rely on any central authority because it's a peer-to-peer process where multiple organizations are supporting the decentralized ledger. Really, to simplify that down, and you probably listened to that last 5 minutes and kind of went, well, I'm still really confused about what blockchain is. Really, what blockchain is just another form of a database. You have databases now in terms of your ERP and your CRM systems, in terms of a lot of your financial systems and that. These are centralized databases which you use to manage your business systems. What a blockchain is a distributed database, so it's not sitting on one centralized set of servers, but it's distributed across a number of different servers in a peer-to-peer network. It's a distributed ledger, so the ledger is managed by all the people in that peer-to-peer network, and it's just one form of distributed ledger that's secure. So really, if you think about it, that's the way you can kind of place what the blockchain technology is. It's just a different type of database, but in this case, it's distributed. It's a distributed database, so it's not in one central location, but it's in multiple locations. It's a distributed ledger, which a ledger is a record of actions or transactions, and it's designed to be secure based on the methodology, the cryptographic methodology that they use. So what are some of the potential uses for blockchain? Well, cryptocurrencies, Bitcoin is one, and there's not just Bitcoin, there's a number of different cryptocurrencies that you can use. Smart contracts, so for example, property contracts or supply chain, or being able to track contracts between two parties. You don't necessarily need a trusted authority in order to manage those contracts. For example, for property rights in, for example, third world countries, instead of having to rely on the central government, which in some cases may be a bit of a challenge, you can use blockchain to basically support those contracts by providing an immutable ledger which shows the transaction of when a property has been sold from one individual to the next. Non-for-profit organizations can use this to manage their transactions as well. Governments and national currencies are big consumers of blockchain. It's funny, when I think Satoshi Nakamoto came up with the idea of blockchain, his idea was to try and get rid of the centralized trusted authorities like banks and governments. The reality is these days banks and governments are actually the two of the biggest investors in blockchain technology. And as I said, bank transactions are a good example of that. Probably the biggest use of blockchain these days is in terms of logistics, traceability in terms of products, managing supply chains. It's probably one of the biggest examples of how blockchain is being used. So what are some examples of blockchain? For example, SWIFT, which is the Society for Worldwide Interbank Financial Telecommunications. In other words, the SWIFT transaction that manages the movement of money between banks has just completed a successful proof of concept for blockchain and are looking to use that in their technology. Some organizations, for example, use it to manage their transactions, overseas transactions. So, for example, Tokyo Marine Nishido is using it to manage claims made by overseas agents to be able to provide traceability. As I said, a common use of blockchain is in terms of managing property transactions. So Propi is another organization, for example, that's using it to manage property purchasing. The UN World Food Organization is using it for food traceability. So in their case, for example, if they're giving foodstuffs or materials to refugees, they want to be able to trace that the materials are actually going to the refugees and people aren't stealing it. So they're using blockchain to be able to provide that traceability, to validate that the stuff that they're doing as part of their food program is actually getting to the refugees that they need. And they're doing that with a combination of blockchain and biometrics for people security, so they know that the food aid is actually getting where they intended to go. You also see it in medical, for example, medical records. So there's a number of organizations that are building blockchains that can be used between hospitals to store and transact on people's medical records. And another big example is in food safety. So being able to use blockchain to provide traceability in terms of where a foodstuff has come from, when it was first produced, how long it's been sitting in storage, whether it's been inspected or not, and how did it got to your table. So Walmart in China is actually using blockchain to manage this. This is another good example. So what are some of the strategic planning assumptions that you need to make for blockchain? Well, according to Gartner, by 2023, blockchain will support almost $2 trillion in goods and services annually. But what's interesting is that 80% of these projects actually won't be in the financial sector. As I said, supply chain is actually a big area for the use of blockchain. So blockchain is moving outside of finance into other areas of business. A lot of blockchain projects are going on in Asia right now. So this is a hotbed for blockchain. But there are challenges in terms of the governance processes, and there's a lot of technical issues and a lot of things that people need to be aware of, because you do have a lot of choices when you're looking at blockchain, which I'll talk about in a minute. Now, some of the advantages and challenges with blockchain. Well, under the advantages, It solves the double spend problem. Like I said, you can ensure from an electronic perspective that currency isn't being sent to two different individuals. So it eliminates the need for trusted institutions such as banks and governments. And in so doing, it democratizes the finance system. It allows you to provide your own systems and processes and systems for being able to manage finance. However, there are challenges. The proof of work system that the blockchain currently is based on, particularly one for Bitcoin, is extremely power consuming. There's comments that say, are there statistics that show that 2 to 3% of the world's power consumption currently is being consumed by the Bitcoin blockchain because it uses a proof of work style method in order to support the blockchain. The other issue that you have to understand with blockchain is it's only as good as the people who are supporting it. The idea is that if there's more people supporting the blockchain than working against it, then it will be secure. If you have a scenario where there's actually more people or more computing power working against the blockchain that you're using, then it actually can be possibly hacked, and that is a problem. It does require the use of complex cryptographic techniques, which makes it hard for people to follow and understand. And it can be used to support illicit activity because it eliminates the need for banks or central trusted institutions. It is, by definition, a tool set, a blockchain, and currencies it supports, or the cryptocurrencies it supports, like Bitcoin, are the prime method of transacting illegal commerce. By some estimates, up to 50 to 60% of the commerce that goes on using Bitcoin is illegal commerce of various descriptions. And as I said, it's subject to this issue of 51% attacks, where if there's more people actually attacking your specific blockchain than supporting it, then you can get into it. So the question is really, is blockchain the right solution for you? Where there's a few things or a few questions you can ask yourself, which will help you decide. Right? Recognizing that blockchain is essentially a distributed ledger system, right? A form of distributed ledger system. Well, the first thing is, well, what are the advantages of centralized databases over distributed databases? Well, the first one is they usually provide you with deep integration. If you have a centralized database, it's very easy to integrate. You control the data. It is more efficient, requires less redundancy. It's more adaptive and provides for better control. You can manage it yourself. And it's typically faster. This is probably one of the fundamental challenges with blockchain technologies. If you're going to use, for example, commercial transactions where you need sub-second performance in terms of managing that transaction, then you're really going to need a centralized database. Right now, the blockchain, particularly the public blockchains like Ethereum, it takes upwards of 10 to 15 seconds for you to process a transaction. That's simply not sufficient for financial transactions, for example, using credit cards. As I said, it's too slow for some form of transactions. It is a fundamentally inefficient data structure in the sense that you're keeping the same data in multiple different locations. It is costly to maintain and develop, and it's not that simple to deploy. That all being said, it's the following two reasons why people do pick blockchains. First of all, it provides you with an immutable, and remember, immutable means unchangeable, ledger that has high degree of integrity, high degree of auditability, and a high degree of authenticity, right? And it's used to solve coordination failures, provide horizontal integration, and avoid centralized corruption. So you are not relying on one centralized database, one central authority. It provides you with a high degree of coordination capability. So for it's these last two reasons that people will more often than not consider blockchain for their solutions. Now, if you decide that you actually do want to use blockchain, then there are a number of different types of blockchain that you need to consider. There are public blockchains. These include things like Bitcoin, the one that supports Bitcoin, and Ethereum, which is probably the most well-known one. But then there are what they refer to as permissioned ledgers or smaller ledgers that are either supported by consortiums, so a number of different companies get together to build their own blockchain, and examples of this are Ripple, R3, and Hyperledger. And then there are private blockchains that organizations build themselves, for example, JP Morgan's Quorum and BankChain. For example, the Australian government has their own private blockchains that they're using for their military activities. The other thing you have to be able to understand is that there are different types of ways that technologies that the blockchain works on. There's different proof programs that they use. So you'll often hear this term proof of stake versus proof of work. Most blockchains these days work off of proof of work, the idea being that you have to solve this complex cryptographic puzzle to add onto the blocks, and that's what provides the immutability. But there are other methods that are coming along now, for example, proof of stake and all kinds of other ones. So like I said, you have proof of work, which is the current blockchain standard led by Bitcoin and followed by most networks. But you also have proof of stake. This is basically, instead of people trying to solve a cryptographic puzzle, people basically stake tokens which have value. to be able to prove that the transaction is valid. There's also something called proof of activity. There's proof of capacity, and there's proof of burn. So these are all different types of blockchains technologies that you could possibly be using in your blockchain if you so choose. Which blockchain offering is for you? Right now, there's probably over 50 commercially available blockchain offerings. The ones that people recognize are Bitcoin, which is the blockchain that supports the Bitcoin cryptocurrency, but also Ethereum, which is the most common public blockchain. But then a number of the major vendors have their own blockchains. For example, Microsoft has one, Oracle has one. There are a number, IBM has one, and then there's a whole bunch of other different blockchains, which all have their strengths and weaknesses. So there's a lot to choose from in terms of both the technologies, the type of blockchains, right? And really the challenge you're going to have is when you look at all these vendors and all these different blockchain technologies and solutions, there'll be a fundamental trade-off, and that is that you'll have to make a trade-off between the degree of security that the solution provides versus its decentralization versus its scalability. And you really, the issue here is you can only have two of these three when you pick a blockchain solution. So you really have to ask yourself a question: what's more important, decentralization, security, or scalability? You can only have two of those three. Once you pick those two, then that'll help you select which vendor and which type of blockchain, whether it's public or permission, whether it's proof of work, proof of stake, these kinds of things. So if you're looking at a blockchain solution, here are the questions that you should be asking yourself, the smart questions. If you boil all my previous 10 minutes down to the key questions, these are the ones that you should be asking yourself about. If you're thinking about blockchain, this is what you should be thinking about, and this is what you should be asking your technology people. First one is, do you really need a blockchain? Is some other form of database more appropriate? Recognizing the challenges and the disadvantages that blockchains have, being a decentralized, immutable ledger. If you're going to go with a blockchain, then what type of blockchain do you need? Do you need a private versus a public versus a consortium? And are you going to use proof of work, proof of stake, or one of these other technologies that people are coming up with? There are over 70 different blockchain offerings on the market. Which one is the right for you? Just like any other software selection, you should be going through a selection process, evaluating your needs and wants, documenting those, and then comparing all the different solutions to those needs and wants. These days, people tend to default to Ethereum. Ethereum is a good solution, but it is a public blockchain, which means it has certain challenges. One of these other 70 blockchain solutions might be more appropriate to you. So you really have to go through a proper selection process. And just recognize that depending on how you architect your blockchain solution, it is not guaranteed to be 100% secure and reliable. A lot of people have this misconception that any blockchain solution is by definition secure and reliable. It is not. There are different degrees of security and there are different degrees of reliability, again, depending on which of the offerings you pick, which of the types of technologies that you use, these kinds of things. So you really need to be asking yourself a question, what's going to happen if you do get a 51% attack? What's going to happen if one of the nodes goes down in your distributed network? What happens in the various issues of the technology? So you really need to do a security and reliability assessment on the technology you're using, because don't be misled by this view that it is, in all the cases, in all situations, 100% secure and 100% reliable. Anyways, that was my 10-minute tech talk on blockchain. Hopefully you found it useful. Hopefully you figured out some of the key questions you need to ask your technical folks. If you have any other questions around blockchain, feel free to send me an email at that email address below, or if you use that QR code, you can connect up with me on LinkedIn. Thanks.